Hey my friends, in this video we are going to be talking about word problems and applications using exponential models. So in class we talked about how there are 4 possible equations. You do not need to memorize them. You will be given them on any assessments you have and can always refer back to your notes to find these formulas. But basically we have 4 different formulas which are all used in different situations. So the first 2 look pretty similar. Notice the only difference is the addition sign for 1 plus r or the subtraction sign for 1 minus r. In both of these situations, P represents the starting amount or cost or population. A represents the final amount, which is usually what we're trying to figure out. R represents the rate, and remember that has to be as a decimal. So if we are given a percentage, we're going to need to convert it to a decimal, and we can do that by just taking the percent and dividing by 100. And T is going to be time, and it might be in years or in hours or in days, but that would be explicitly given in the problem. And we are going to use the first equation when something is increasing or growing or gaining value. And we're going to use the second equation when something is decreasing, or sometimes you see the word depreciating, like a car depreciates in value because it loses value over time. You might see the word appreciate. It means increase in value. So we have those 2 similar formulas. One, the plus, we'll use for something that's increasing, and the minus we'll use for something that's decreasing at a steady rate each time period. Then we have our other 2 formulas here, and we are going to use those for usually more problems talking about finances and growth that happens not just once a year, but maybe happens a couple times a year. So we call it compounding interest. And basically what that means is if you get, let's say, a 12% interest rate, but it's compounded monthly, that means you would get 1% interest each month because there's 12 months in a year. If you got 12% interest compounded quarterly, that means you would get 3% interest each month or each quarter. So you would get 3% 4 times a year, giving you 12%. So we want to compound interest because that means you get your interest payments more frequently, and therefore your total balance increases, and then you basically get interest on your interest. So for these second 2 formulas, P is still going to represent our starting amount, A is still going to represent our final amount, R is still rate, T is still time. But in the second equation, we have this value for N, and N is the compounding period. So there's a couple key values that happen a lot. Monthly would be 12. Quarterly, that would mean 4 times a year. Annually, that would mean once a year. Weekly, that would mean 52 times a year. And those are usually the most common ones. You might see like semi-annually, which would mean twice a year, but usually those 4 are most common, or something like daily, which would be 365. But those are the compounding periods, and they come from how many times it happens in one single year. And that is your N value, which appears twice in the problem. And then, don't forget, we have a little t here that I drew over. This exponent is n times t. And then our very last equation here in orange, we're going to use for things that are being compounded continuously, which means literally all the time, every second, every millisecond. Would be great if this happened with money. Sometimes that's the word problem situations, but it's not super realistic. It's more kind of almost like bacteria growing, or something that doesn't start and stop, is continuously growing. And for this problem, similarly, A, P, R, and T are all the same things they've represented in the other 3, but we have this new added element, which is E. And remember, E is not a variable. Okay? E represents a value, so we're not replacing E with something in the problem. E is a special number similar to pi. And like we have pi, which is equal to 3.14, and you learn about that in geometry. I'm sorry about that. E is equal to 2.72 approximately. And if you have a calculator, just make sure you can locate your E button. If not, it's on your phone as well. But if you hit E in your calculator, you'll get that it is equal to 2.71828, and it's one of those irrational numbers that goes on forever. So we usually approximate it at about 2.72. So like in geometry where you had formulas like pi r squared and 2 pi r, pi again isn't a variable, it's already assigned a value 3.14. E is not a variable, it's already assigned a value 2.72. And ideally you have a calculator that has the E button on it. If not, you could approximate by just using 2.72 where you see an E. So now we're going to just talk about how you know which formula to use and how to use it. So we're going to go through 4 quick examples, one of each type. So you have an inherited land that was purchased for $30,000 in 1960. So that's going to be my starting amount. That's going to be that P value. And the value of the land increased, so it's going up by approximately 5% each year. So because we are increasing each year, we're not talking about compounding interest, we're not talking about compounding continuously. My big keywords are increased each year. So I'm going to use this growth equation. And it is increasing 5% each year. And the question is, what is the approximate value of the land in the year 2011? So first, let's identify all the things. A is what I'm trying to figure out. I'm trying to figure out what is the value of the land in 2011. P is my starting amount, and it starts at $30,000. And R is my rate, and they tell me that my rate is 5%, but I want to convert that into a decimal. So 5% as a decimal is 0.05. If you're not sure how to find that, you can either take the percent and move it to the left twice and get 0.05, or you can always take 5 and divide it by 100 in your calculator, and that will get you 0.05. So my rate is 0.05. Before we go to answer the question, most of the ones we'll see have 2 parts and first ask you to write the model. So the model just means, in general, can you represent this situation? If I got some land that was worth $30,000 and it increases at 5% each year. So that means A is going to equal 30,000 times 1 plus, because I'm increasing, my rate is 0.05 each year. So T represents time. And I can simplify that a little bit to just be 30,000, 1.05 to the T. So this would be when asked for the exponential model. This is the model that represents the situation. And notice I haven't replaced T yet because then it's not a model anymore, it's finding an answer. So we want to keep T a variable so that we can use this model at any time. In this specific problem, the question was, okay, then what is the year worth in 2011? That does not mean T is 2011. T is how many years have gone by. So from 1960 to 2011, how many years went by? Well, that's 51 years. And I can find that by just subtracting these two. So T is 51. So I'm going to have A is equal to 30,000 times 1.05 to the 51 power. And from there I can get my calculator. Remember exponent first, so 1.05 to the 51 power. And then I'm going to take that answer, which was 12.0407, I'm going to multiply it by 30,000. So I end up with 36,100. Oh, sorry. Not 36,000, my bad. 361,200 $223.09, right? And because we're doing money, we can just do 2 decimal places. If you put about $361,223, that would be fine too, because it does say approximate. Okay, moving on to the next one. An adult takes 400 milligrams of ibuprofen. Again, there's my starting amount A. Each hour, the amount of ibuprofen in the person's system decreases. So I am decreasing, so I'm going to use my decay function at a rate of 29%. How much ibuprofen is left after 6 hours? So before we answer that, again, let's write our model. So we need to identify what A, P, and R is. My A is 400, because that's what I'm starting with, how much ibuprofen I started with. My R, sorry, not my A, my P, my bad. My starting amount is 400. My R is my rate. Sorry, I'm all over the place right now. Next page. My rate is 29%, but I can't put 29 in for R. I need to convert that to a decimal. So my rate is 0.29. And then A is what I'm trying to figure out, how much ibuprofen is left after 6 hours. And for my model, remember, I'm only using these 2 things because I want a model that works for everything, for 6 hours, for 7 hours, for 8 hours, and so on. So my model would be A equals 400, 1 minus, because it's decreasing by a rate of 0.29 to the t power. And I can simplify here and do 1 minus 0.29, which is going to get me 0.71 to the t power. So there is my model. And now I'm going to actually answer the question, how much ibuprofen is left after 6 hours? So that means my t is equal to 6. So A is equal to 400 times 0.71 to the 6 power. So 0.71 to the 6 power gets me 0.1281, and then I'm going to multiply that by 400, and I'm going to get 51.24. Let's see what units were in here, milligrams. So I took 400 milligrams of ibuprofen. My body's using that up. After about 6 hours, there would be 51.24 milligrams left, right? It makes sense that I got something lower because it is decreasing the amount in my system. Okay, question 3. If you deposit $4,000, there's my P, my starting amount, into an account paying 6% annual interest compounded quarterly. So there's a bunch here. I have my rate, 6%, compounded quarterly. That tells me my N value. So quarterly, remember, means 4 times a year. How much money will be in the account after 5 years? So I'm going to start with my model, substituting in just the A, R, the N. Sorry, I keep saying A, the P, R, the N. So how much money will I have if I start with 4,000? I'm using this equation because it's compounded quarterly. So I start with 4,000, that's my P. 1 plus, because we're increasing, we're getting that amount paid. So 1 plus, my rate is 6%. So 6% is 0.06. So 0.06 over compounded quarterly, N is 4. And then here, another N is 4. T. So I'm going to simplify just the inside of my parentheses here, and then I'll have my model. So 0.06 divided by 4, and then plus 1. So that gives me 1.015. So there is my model. And now I can use my model to figure out after t years. So A is equal to 4,000, 1.015. And here is 4t, means 4 times t. So this would be 4 times 5. Or, to make your life a little bit easier, we can just write 20. So I'm going to do 1.015 to the 20th power because we do exponent first. Then multiply by 4,000. And that means after 5 years, if I start with $4,000, I would have $5,300 $1,287.42. Based on this account, that was compounded 6% annually, quarterly, so 4 times a year. Okay, last and final one. Guess what it's going to be? So Pedro opened a savings account and deposited $300 as his principal, as his starting amount. The account earns 15% interest, so that's going to help me find my R. It is compounded continuously, meaning every single second, millisecond, time of the day, you're getting more money added to your account, you're earning some interest. So because it is compounded continuously, I'm going to use this special formula. I'm going to write the model first, but then I'm going to find the balance after 7 years. So for my model, all right, I'm going to pause 2 seconds because my dog is staring at me to open the door for him. Maybe you can write your model while you're waiting for me. There you go, bud. For your model, we're using this fourth equation for compounding continuously. So A is equal to, Pedro starts with $300. E, remember, is not a variable. It's not getting replaced. It already represents a number, 2.7. So 300E. My rate is 0.15 for 15%, so 0.15 T. And then now I'm going to evaluate, so 300 times E, this is 0.15 times 7. So I like to do that part first. So 0.15 times 7 is going to get me 1.05. And now I'm going to do exponent first, so E to the 1.05 power. That gets me, I'm just going to write this for a second. I have an E button on my calculator, so that gets me 2.85765. And then I multiply that by 300 to get my final answer, which is 857.29. But I just want to say, if you can't find the E button on your calculator, it's not great because it's an approximation, but you could do 2.72 to the 1.05 power. I just want to show you the difference. So if I do 2.72 raised to the 1.05 power, because that's what E is, and then multiply by 300, I get 857.86. So just slightly more for rounding up because it's really 2.718. So if you have an E button on your calculator, use it. If not, if you're like, I don't have a calculator, I'm using my phone, then instead of E, we can just use the number 2.72. So 2.72 to the 1.05 power, and then multiply by 300. But either way, you have about $857 after 7 years. So hope that helps. That was one example of each of the types of word problems that we have talked about in class. Let us know if you need anything.